is a factor?
Like the numbers when you multiply them.
Mm-hmm.
Yeah.
Yeah, that's exactly it. They're numbers that when you multiply, you get another number. So factors are numbers, and they're usually positive numbers. Numbers that can be multiplied. Together to get another number. And I'm sure that there is a much better mathematical definition, but you've already kind of learned this. This is kind of just a refresher about what factors are, what GCFs are, what LCMs are, prime factorization, all that kind of stuff. So what is a greatest common factor?
So like when you're factoring stuff,
Mm-hmm.
like if there's like say 3 5s,
Mm-hmm.
5 is the greatest common factor because it's the one that they all have in between.
Yep. Good job. So greatest common factor, another term, you might see this as just GCF, but it stands for greatest common factor. And it is the largest, so the largest common number that divides exactly into 2 or more numbers. So it's basically just like the number that is the biggest common number between them when dividing. So when it says that it divides exactly, that just means when I divide, I don't get decimals. So it goes evenly. It goes in 5 times or 6 times, not 5.7 times. It's an even value, whole number, no decimals. Now, a least common multiple is basically the same thing. We refer to this as an LCM, least common multiple. That's the smallest, okay, the smallest number that 2 numbers both divide evenly into. So the one thing that you want to make sure that you pay attention to is we're going to be working a lot of division, a lot of multiplying. So being able to do multiplication facts is going to be the best way to learn this. And starting next week, we will practice multiplication starting after your test. Like we will do those elementary multiplication quizzes where you have to solve them in a minute. Eventually, it will be a quiz grade, okay? All right, prime factorization. This I'm going to refer to as PF, just because writing prime factorization over and over and over again is not fun. So if you see PF, like for example down at the bottom, that just means prime factorization. Prime factorization is finding the factors.
On the greatest common factor, what's the last part? The same 8.
2 or more numbers. Mm-hmm. Sorry, it's really hard to zoom in and have you see everything.
No, I know, but it's fine.
So finding the factors of a number that are all prime. So prime factorization is when you break down a number into numbers that are prime that when multiplied together get back to that number. So before we start prime factorizations, what is the smallest prime number? The smallest prime. No, 1's not prime. 2. So when we do prime factorizations, that's why you don't break it down into 1 times the number. Because 1 is not a prime number. 2 is the smallest. So prime factorizations, good job, Kinsey. Prime factorizations is where I break down a number into its prime values. All right, so let's practice that. So we want the prime factorization of 144. The first thing you have to do is kind of make a factor tree. Do you remember making factor trees in Algebra 1?
Yeah.
Okay, what two numbers multiply to give me 144? Sure, 12 and 12. Is 12 a prime number? No, which means you're not finished. You've got to break it down again. So how do we break down 12 and 12? 3 times 4, that works. You could also do 6 times 2. Here's the good thing about prime factorization. You don't have to pick the same multiplication pieces. You can pick 3 and 4 or 6 times 2. They will all break down the same. Is 3 prime? Yes, so I leave it. What about 4? No. How do we break 4 down?
2 and 2.
2 times 2. Okay. 2 is prime, so we jump to 12 over here. Now, obviously, you can copy it because you're going to get the same answer. 12 is not going to break down any different. How do we feel about this? Do you remember kind of breaking the factor tree down? Okay, now to put it in prime factorization, all of your answer pieces must be prime numbers. So you start with the smallest. My smallest prime is 2. How many times do I see 2 in my problem? 4 times. So I have a 2, a 2, a 2, and a 2. You just write 2 to the 4. That's it. Because all of these things are being multiplied. So it's just 2 times 2 times 2 times 2. Okay, what's my next prime?
3.
Yeah, my next prime is 3. How many 3s do I see? 2. So 3 to what power? 3 to the 2. So we just put solid, big dot, 3 to the 2. Okay, now that solid dot means multiplication, but this is more exaggerated than this tiny little multiplication symbol. This just lets you know that this is a prime factorization. It's a slightly over-exaggerated multiplication dot. When it's typed on your practices, you'll see it. It's a little bit different. And that's all you do. That is the answer. However you were to break down 144, you will eventually get the same answer. One way might be faster. You know, if I started with 2 times whatever, that would just take a little bit longer to break down. So try 256. Remember, you're breaking it down to just primes. That's why we don't put 1 in here at all, because 1's not a prime number. So take a second, try 256. Now you did it. I did 16 times 16. Then from here, I broke 16 into 4 times 4. Then from there, I broke it down into 2 times 2, 2 times 2. It's up to you. You don't have to do it that way. You could do 256 and divide that answer by 2. Eventually, you will get down to the bottom where it's all 2's. So what is our final answer here? 2 to the 8th. All I do is count how many 2's I see. Well, 1, 2, 3, 4, 5, 6, 7, 8. 2 to the 8th. And that's your answer. You don't have to have 2 different numbers. You can leave it like that. All right, let's talk about GCFs. So this is called prime factorization, where you break it up into prime numbers raised to exponents. A GCF, this is kind of like when you're factoring, you pull out the greatest common factor, something that divides evenly. Now, if you're not sure, okay, you're looking at this problem and you're like, I have no idea what my common factors are. All you have to do is treat it like the prime factorization. Break it up like that. So I'll show you this way first, and then we'll talk about multiplication skills. So let's break down 84x cubed. How can we break up 84? Six. You test it. Just do 84 divided by 6. So you can always test these answers.
Yes,
It does. 6 and 14. So you can break it up this way. Again, if you have no idea where in the world to start, if it's even, just divide it by 2. So if you're stuck and don't know, even numbers, 2 always goes into it. So 6 is not prime. How do we break 6 down? 3 times 2. Are those both prime? Yeah, so you can stop. How do we break 14? Yeah, 7 times 2. Both of those prime? Yeah, so you're done. Now, x to the third, I can break that down into x times x times x. Remember, when I'm adding my exponent is 1 plus 1 plus 1 is 3, x to the third. Now, you're going to do the same exact thing with 36. So how do we break 36 up? 6 times 6. And then again, 6 is not prime, so we've got our 3 times 2. 3 times 2. Then break up x squared. So x squared is just x times x. So what we've done is we've broken it down to its prime factorization. The way that you write a GCF is now you kind of put it back together by pairing it up. So the way that you pair them up is you look at each answer and you say, what numbers do they have in common? So let's see right here. I have a 3. Do I have a 3 over here? Yeah, so I can pair 3 up with 3. And I'm just going to write it once because I'm multiplying. I'm re-putting it back together. Any other values that they share? 2. How many 2's do they share? 2 2's. So what I'm going to do is group it. This 2 pairs with this 2. This one pairs with this one. So I'm going to get 3 times 2 times 2. Do they share any other numbers? No. So I'm going to leave 7 and 8, or 7 and 3, because those don't go together. How many x's can we pull out? 2 x's. I have an x here, and 1 and 1. So this becomes times x times x. Now again, this is like if I totally forget what I'm doing, I have no idea what to do, this will always work. However, the stronger your multiplication skills are, the way easier that this becomes. So now you're just going to combine. 3 times 2 times 2. 3 times 2 is 6, times 2 is 12. X times x, x squared. This is the GCF for those numbers. Now, on the next page, when we talk about factoring it out, this is where you would put the parentheses after it, and then you would put your answers after as well. So try the next example. Remember, you want to group everything together. So break it down, group it together. Or if your multiplication skills are good, you can just divide 72 by 3 and see if 4 goes into it. You're looking for the even values. To do this one, 72 breaks down into 2 times 2 times 2 times 3 times 3. And then I broke my x's down and my y's. 4 only breaks down into 2 times 2. So I can only pull 2's out from each. I'm pairing them up. So 2 times 2 is 4. I can pull out 2 x's from each. So that becomes x squared. And then I can pull out 1 y. What? Well, there's only 2 2's here.
No, I'm talking about the egg.
This is only x to 2.
No, it doesn't.
On this one?
No, like on the same problem, like they're like 5 X's.
Right, but you're matching them together. So there's only 2 over here. So you can only pull a maximum of 2 out here. They have to match. So like, for example, here, we only had 2. So 2 can only match 2. So there'll be some that don't go with it. You're pulling out all of the matching pairs. So I can only pull and match 2 evenly because this one only has x squared and this one only has x5. I can't match up more than what I have in each. It has to go like, you're comparing them separately. So I can match this x with this one and this x with this one. I have nothing else to match x with.
Oh, I thought you could like do it on the same you match both of them.
No, like this is a separate and this is a separate. You group them from there. Does that make more sense? Yeah, they're separate. Okay, tomorrow we'll start on page 10. Make sure that you've got your homework done. Those new IXL codes